So we're going to go over number 13. I might switch back and forth between the document camera and the answer key and just taking a video of the screen. So what you can see here first is that I tried putting it in the calculator. So in number 13, you have to find all the roots, which means that you want to find all of the zeros, or what will make the equation zero, like what x values. But unfortunately, it didn't work out that well for me, so I tried a different way, and I think the way that I have down here is the way that it was looking for you to solve it. So in order to find all the zeros, we want to factor it. So factoring, meaning I want it in two sets of binomials. So usually your exponent is x squared, but in number 13, it was x to the 6th. But I noticed the middle term was x to the 3rd, and then the last term didn't have any x's. So what I did was I factored x cubed times x cubed is x to the 6th. And then you have outside is negative 64x cubed. Inside is positive 1x cubed. So you could see that here. Then what I did was, this is called the sum of cubes. It's a formula here, which you probably went over at some point. The sum of cubes means you're taking the sum, or you're adding two cubes. This is x cubed, this is 1 cubed. So the formula is a cubed plus b cubed is equal to this, where you have a plus b times a squared minus ab plus b squared. So in order to factor this now, I found that a was x, b was 1, so I have x plus 1, and then I plugged in x squared minus a times b, which is x times 1, so minus 1x, plus whatever b is squared. B times b is b squared. Then I have the difference of cubes. I have a cubed minus b cubed. So I have a minus b. This is something cubed. This is something cubed. So I have, that's x cubed. This is 4 cubed. So I have x minus 4. Then I have x squared plus 4x plus 16, because it's x squared plus a times b, which is x times 4. So that's where I got the 4x plus b squared. And remember, I said b was 4, so 4 squared is 16. So when we're solving for 0, we're looking for what's going to make this 0. So because it's x plus 1, the value negative 1 is going to make this 0. If we look here, the value 4 is going to make this 0. Then you can look to factor these two trinomials. Unfortunately, they're unfactorable, which means you can't do like two sets of parentheses like we did up here. So I used the quadratic formula. So I did the quadratic formula for this one here. You'll see that I got two answers that are imaginary. So I plug in for the quadratic formula 1, -1, and 1 for A, B, and C. We put in -1 for B, so opposite of B, plus or minus square root of B squared minus 4AC all over 2A is the quadratic formula. So B is -1, so we have negative of a -1 is 1, plus or minus the square root. B is again -1, so -1 times -1 is just positive 1 squared, or 1, minus 4 times A times C. So A is 1, C is 1, so it's 4 times 1 times 1, all over 2A, and A again is 1. So then I figured this out. I simplified it. So 1 squared is 1, minus 4 times 1 times 1, which is 4. 1 minus 4 is -3. -3, we don't like negative in a square root, so you can take out a -1 from this, like divide by -1, which means I take an I out because I really represents square root of -1. So this is your answer for this. For this trinomial, these are your two answers. And I know I'm supposed to get 2 because of the exponent. I only got 1 here because of the exponent of 1. So there's 1, there's 2 for a total of 3, there's 4. I should have 6 because of the original problem. Then here I needed to use the quadratic formula for this one as well. So then my A was 1, my B was 4, my C was 16. I plugged in the values here for A, B, and C. Over here, I simplified. I noticed this square root had a negative inside as well. So then I pulled that out by putting an I here. I also simplified this 48 because if you remember simplifying radicals, you look for a perfect square in 48. A factor of 48, that's a perfect square is 16. So then I had square root of 16 is 4, square root of -1 is I, and then what's left in there is square root of 3, all over 2. Since both of them are divisible by 2, over here both of them were not divisible by 2, so you couldn't do this, but -4 and 4 are divisible by 2, so I cleaned that up a little, and then these are the two answers. So I have 1, 2, 3, 4. The reason why there's 2 is because you could have plus or minus, and then 5 and 6.